Hi students, let us start with our new chapter, Linear Inequation. Chapter 4. Linear Inequations. Okay. So, what do we understand from the term linear inequation? It's not equation, it is inequation. Okay, let us go to that. Linear inequations. So, if x and y are two quantities, consider x and y as two quantities. Okay. Then, both these quantities will satisfy any of the following condition. So, if it is two quantities are given as x and y, it should satisfy any of them. Just have a look. X greater than y, x less than y, x greater than or equal to y, or x less than or equal to y. Is it correct? It should satisfy any of this inequation. So, each of these four conditions given below is an inequation. If it's equation, how do you represent? It will be like equal to, right? So in order to compare any two quantities, you can use this inequations, right? Either you can tell that is greater than, less than, greater than or equal to, or less than equal to. Okay. So, let us go through. In this chapter, we'll be learning linear inequation in one variable. So, let us see what is that. Okay. Linear inequations one variable. In your smaller classes, you have learned linear equations in one variable, and you had an idea about linear inequations also. So, let us learn little more advanced of that. In your class 8, you have learned about linear inequations slightly. So, we shall go through little more further on linear inequations. Okay. So, linear inequation in one variable. Let me see what is that. If A, B and C are real numbers. Consider A, B and C are real numbers. Then each of the following is called linear inequation. Each of the following is called linear inequations. That is Ax plus B greater than C, read as Ax plus C greater than C, or Ax plus B less than C, Ax plus B greater than or equal to C, Ax plus B less than or equal to C. Okay. So, solving a linear inequation algebraically. How do we solve the linear inequation? So, before that, let me tell you, these terms like our signs less than, greater than, less than, greater than or equal to, less than or equal to are called as the signs of inequality. Okay. They are called as signs of inequality. Now, let me explain you how to solve a linear inequation algebraically. So, we have certain rules for that. Solving linear inequations algebraically. Solving algebraically. Okay. So, let me see. What is there are certain rules given to us. We have how many rules? Just let's check. So, hope you all have your textbook with you. So, page number 39. So, you have rule 1, 2, 3, 4, 5, 6. We have 6 rules. So, let us roughly go through the rules. Rule 1, and we can compare them. Rule 3, rule 4, rule 5, rule 6. So, what is the first rule given to us? On transferring a positive term from one side of the inequation to the other side, the sign of the terms become negative. Okay. When you transfer when you transfer one of the term, the positive term, to other side of the inequation, the sign becomes negative. So you do the same thing in your equations also, right? So whenever you change from LHS to RHS or RHS to LHS, your positive sign will become negative, right? So let me do one example and show you. 2x plus 3 equals to 7. So what happens to this 3 when I take it to the other side? So I get it as 2x equals to 7 minus 3. That is 2x equals to, 2x plus 3, it's greater than or equal to, okay? Greater than or equal to 2x greater than or equal to 4. This is how you do it, okay? Now coming to the rule 2. It is similar to the rule 1, only thing is, on transferring a negative term from one side of the equation to the other side, the sign of the term becomes positive. So 2x minus 3 greater than 7. So this minus goes to the other side. What do you get? 2x greater than 7 plus 3, that is 10. Okay. Now coming to the rule 3. If each term of an inequation be multiplied or divided by same positive number, the sign of inequality remains the same. So what is told? You have an inequation, and if you are multiplying or dividing by the same positive number on both the sides, it should be a positive number, okay? Both the side of an inequation, the sign remains the same. That is, the sign of inequality remains the same. So let us check. If it's given as 5 is greater than 3, let me multiply a positive number to both the sides. Let me multiply with 10. So what do I get? 50 greater than 30. Yes, it is true. Correct? Similarly, dividing also. So check, I have 15 greater than 10. Let me divide with 5 on both the sides. Dividing with 5 on both the sides, what I get? 3 greater than 2. So the sign doesn't change, right? So it's clear to you. Hope rule 3 is clear to all of you. Now coming to rule 4. What's given in rule 4? If each term of an inequation be multiplied or divided by the same negative number, the sign of the inequality reverses. So if each term of an inequation be multiplied or divided by the same negative term, the sign of the inequality reverses. So what happens? Let me check. Same question we take, okay? We will take 15 and 10. Let us divide. Divide by a negative term, that is negative 5 on both the sides. Negative 5 greater than 2. So what do you get now? Minus 3 greater than minus 2. Is it true? Is minus 3 greater than 2? No. It is minus 2 greater than. So you can write it minus 3 less than minus 2. So in this case, what had happened? The sign is reversed. Okay. Same way in multiplication also it changes. Just have a look. 5 and greater than 3, right? Multiply by minus 10, you get minus 50 greater than minus 30. It's actually less than. Minus 50 is less than. So what do you understand from rule 4? If each term of the inequation be multiplied or divided by the same negative number, the sign of the inequality reverses. Okay. Now coming to the rule 5. If sign of each term on both the side of inequation is changed, the sign of the inequality get reversed. For example, just keep it in mind that we have different signs. That means I am telling that minus 3 less than 2 I have. Okay. So if sign of each term on both the sides, sign should change. Here if sign changes, what I get? Minus will become plus. So it will be 3. And here if sign changes, what will happen? 2 will become minus 2. So 3 and minus 2, how do we compare them? You get 3 greater than minus 2. So what happened to the inequality here? The inequality is reversed. Now coming to the 6th rule. If both sides of an inequation are positive or both are negative, then on taking their reciprocal, the sign of the inequality reverses. So, Again, let me do 5 greater than 3. So, if the reciprocal is taken, you will get 1 by 5 and here you will get 1 by 3. So, which is greater? 1 by 3 is greater than 1 by 5. So, what happens to the sign? The sign get reversed. Okay. So, let us quickly go through the rules again. What is the first rule? In the first rule, if a positive term is there and it's transferred to the other side, it will become negative. Okay. And if a negative term is there, when you change it to the other side, it will become positive. Third rule is, when you are dividing or multiplying with a positive term on both the sides, the inequality doesn't change. Fourth rule is, when you are multiplying or dividing with a negative term, the inequality changes. Rule 4 is that, rule 5, the sign of each term on both the sides of an equation is changed. The sign of inequality get reversed. So when the sign changes, you understood that. Then again, if both the sides of an equation are positive or both are negative, in this condition, either both the sides should be positive or both the sides should be negative. Then on taking the reciprocal, the sign of inequality changes. Okay. Now let me go through what is a replacement set and a solution. So coming to the topic, replacement set and solution set. Okay. Set from which the value of variables x is to be chosen is called as the replacement set, and its subset whose elements satisfy the given inequation is called as solution set. So whenever a question is given to you, set from which x has to be chosen. For example, let the given inequation be x greater than 3 if replacement set n. So, for example, it's given like this is, here we have written replacement set, or otherwise it will be written like this, x less than 3 where x belongs to n. So which is the replacement set here? Replacement set is here natural numbers, and a solution set. If it is natural numbers, what are the terms comes under x less than 3? It is 1 and 2. So this will be your solution set. So again, let me take x greater than or equal to 2. X belongs to w, that's whole numbers. So here whole numbers will be the replacement set, and what will be the solution set in this case? 2 greater than or equal to 2, right? So 2 remains, 3, 4, 5, it goes like that. So whole numbers is still infinity. So you can write the solution set like this. So this will be a solution set. So always remember, whenever you are representing a solution set from the given question, you should always write it in the curly bracket. Okay, it's a flower bracket, you should write in the flower bracket. Only if you just write the terms, it's not the right way of representation. You need to always write it under flower bracket. Okay, so let me start with your questions. That is our exercise 4a. Okay, so in the exercise 4a, the first main you have true or false that you can try yourself. So second main also. So I will be starting with the third main. Okay, you need to write the first main and second main in your class book. It's true or false, you can go through that and you can do it. It's from the rules what we have learned. If you go through that rules, you will get the answer for that. Okay, so let me start with the third question. Exercise 4a, the third question I'll be taking. Okay, dark colors. Okay, so if x belongs to n, it's in page number 44. Okay, page number 44. If x belongs to n, find the solution set of inequation. That is 5x plus 3 less than or equal to 2x plus 18. 5x plus 3 less than or equal to 2x plus 18. So your replacement set is given as n. So first let us solve this. We need to solve the given inequation, then find the answer. Okay, so let me take all the x terms to one side and numbers to the other side. So all these are positive. So when it is transferring to the other side, according to our first rule, it becomes negative, right? So 5x minus 2x less than or equal to 18 minus 3. So 5x minus 2x is 3x. Less than or equal to 18 minus 3 will be 18 minus 3 will be given as 15. Now what happens? You need only x, right? So you need to divide. So you have to divide both the sides by 3. In dividing a positive number, the inequality doesn't change according to our rule 3, right? So you can write x less than or equal to 5. So here you got a term x less than or equal to 5. So let us see what will be our replacement set. Our replacement set will be x belongs to n also, right? So replacement set will be 1, 2, 3, 4, 5. It's less than or equal to 5. So it is 1, 2, 3, 4 and 5. Okay. So there is one more sub question in that. Let me do that also. 3x minus 2 less than 19 minus 4x. 3x minus 2 less than 19 minus 4x. So again, taking x terms to one side, what do we get? 3x plus 4x, second rule. Okay. Less than 19 plus 2. 3x plus 4x is 7x. Less than 19 plus 2 is 21. Divide by 7, divide by 7. X less than 3. If x less than 3 and it belongs to natural number, what are the numbers? 1, 2. Okay. The solution set is 1, 2. Now I will be doing one question from the fourth main also. Fourth main, what's given? If replacement set is the whole numbers, so replacement set is given as whole numbers. So replacement set is the whole numbers. So let me do the first sub question from that. X plus 7 less than or equal to 11. So x is less than or equal to 11 minus 7, that is 4. So it's set of whole numbers. What are the terms coming less than? X is less than or equal to 4. 0, 1, 2, 3 and 4. Okay. So now second and third question is similar. You can do it yourself. Fourth also, I shall start with the fifth sub question in that. Fifth sub question, what is there in the fifth sub question? X minus 3 by 2 less than 3 by 2 minus x. So taking x terms to one side, I get 2x less than 3 by 2 plus 3 by 2. So 2x less than 6 by 2. X less than 3 by 2. X less than 3 by 2. Okay. So if it's x less than 3 by 2, just go through which are the whole numbers coming. X less than 3 by 2 is 1.5. So x less than 1.5, what are the numbers? 0 and 1. Okay. Hope it's clear. Okay. Now let us do the eighth question. Okay. Find the smallest value of x for which? Eighth question. 5 minus 2x less than 5 1 by 2 minus 5 by 3 x. So 5 minus 2x less than 5 2s are 10. 10 plus 1, 11 by 2 minus 5 by 3 x. So what do we get? 5 minus 11 by 2 less than 5 by 3 x plus 2x. Okay. So what do you get? Minus 5 by 3x. Okay. Or you can take it to this side also. Wait. We'll take it to this side. Then there won't be any confusion for us. Okay. So minus 2x plus 5 by 3x less than 11 by 2 minus 5. Minus 6x plus 5x by 3 less than 11 minus 10 by 2. Okay, LCM. So what do you get? Minus 1, that is minus x by 3 less than 1 by 2. Taking 3 to that side. Minus x less than 3 by 2, not minus, it's 3 by 2. Minus x less than 3 by 2. So, multiplying with negative on both sides to convert this negative, the inequality also changes. X greater than minus 3 by 2. Okay. So, x greater than minus 1.5. X greater than minus 1.5, and what is given? The smallest, find the smallest value of x for which this equation where x is an integer. X should be integer. What is the smallest value of x? X greater than minus 1.5 means x should be greater than. So what is the smallest integer from that? X is equal to minus 1. Okay. Minus 1.5. Next greatest number is, greatest integer is minus. Now let me do the okay. Let's do the 11th question. What's given in the question number 11? Given x belongs to integers. Okay, you can see x belongs to integers. In the previous question also we have taken this minus 1 because x belongs to integers. That's the reason, and they didn't ask you for the solution set. They have just asked you for the smallest value of x. That's why I have written minus 1. If they ask for the solution set, we have to write like this. It is, what is that? Minus 1, 0, 1, it continues. Okay. But they had asked only for the smallest value, so I have written minus 1. So let's see what is that. X belongs to integers. Find the solution set of, okay, let's see how to solve it. 5 less than or equal to 2x minus 3 less than x plus 2. So in this type of questions, what do we do is we need to separately solve, okay, both. So first we take only this much. How much you will be taking first? It will be only, okay, you will be taking this much and solving, okay. So what do you get? Minus 5 less than or equal to 2x minus 3. So minus 5 plus 3 less than or equal to 2x. So you get minus 2 less than or equal to 2x. Divide by 2 on both the sides. So what do you get? Minus 1 less than or equal to x. X greater than or equal to minus 1. So if it is integers, x greater than or equal to 1. So it's not over. Now we have the other part. Okay. This part we will be solving. Okay. So what is given? 2x minus 3 less than x plus 2. 2x minus x is x. X less than 2 plus 3, that is 5. So finally, what is our conclusion? Totally, we have one question, so we got the first part here and the second part. When you combine, what you get? Minus 1. When you're combining, you will get minus 1 less than or equal to x less than 5. Okay, this will be our final answer. Now tell me what are the integers which will come in between this range. So minus 1 less than or equal to x. So minus 1 is included. 0, 1, 2, 3, 4.